we're just going to kind of continue our conversation around probability. So when we talk about what is probability, if I ask you to define probability, but let's see, I'm going to rule out a few words that you're not allowed to use because I think they're the same rules or same words that are also as ambiguous as the probability something happens. Okay. So if I said you weren't allowed to use the phrase the chance, likelihood, I'll start with just those two. If you can't use the word chance and you can't use the word likelihood, how can you describe what, you can't use the word odds, because probability and odds are different. What is probability? Because if you say it's the likelihood that something happens, I don't believe that explains probability any different than saying it's the probability or chance. So what does that really mean to say something has, for example, a 25% probability?
The amount of time one thing or another would happen.
Say that again?
The amount of time one thing or another would happen.
Well, so it's related to that for sure. But like, let's go ahead and talk about something with a 1 in 4 probability. And so we're going to say this spinner blew. I can't hold up the spinner and spin it because it has like a weighted thing. It stops being like an actual probability spinner. But like, the time in which it lands, like that amount of time, is very tiny, right? Okay, and in fact, in this case, it's on red. This case, it's going to be on red, yellow, green, blue. But there's something I know about probabilities. What's the largest probability something can have? 100%? Or, so it's a number between 0 and 1. Like if you say something has a probability of 1.2, we have a problem. Yeah? Okay? So, well, Eleanor, I love where you're going, and you definitely are on the right track. To say it's like the amount of time or the amount of time something happens, it's problematic because I could if I could spin it 100 times, I'm not going to, and I get 25 blues, 25 isn't the probability. It's not the number of times something happens. It's the ratio, the proportion. To use the fancy statistics word we used at the beginning of the year, the relative frequency. But as we talk about that relative frequency, okay? So I just spun it 6 times, and we got a blue 1 out of those 6 times. So that's what, 18%? You guys see what I'm saying there? And then I keep going. 1 out of 7, 1 out of 8, 1 out of 9, 2 out of 10, 2 out of 21. Are you guys with me that it hasn't hit 25% yet? And in fact, it's going to keep bouncing, okay? And for the beginning of any probability of that, it bounces a ton. It's all over the place. Okay? But what's going to happen if I spin that spinner 1,000 times 1,000,000 times, what would we expect to see? If we spun it 1,000 times, how many times would we expect it to be on blue? About 250 times. Okay? Because the minute I have a large number of trials, probability is very predictable. But if I say it's the relative frequency that something's going to happen, and I only do 4 trials, probability is pretty bad. So a huge idea is this concept of probability is only useful in describing what would happen for a large number of trials. That's a big idea. Like, huge idea. We sometimes call it the law of large numbers. And people are really, really bad at understanding the law of large numbers. You will find many, many people in the future, in your future, who will use the law of large numbers incorrectly. As the person who ran the staff lottery pool for as long as the Powerball was big, I promise you, there are many adults in this building who don't understand the concept of large number of trials and the law of large numbers. Everybody okay? Now, have you guys, do any of you guys have Apple Care or any sort of warranty on your phone? Where if you break your phone, you can take it in and it's like a cheaper warranty type thing. How many of you have car insurance? All insurance follows probability models. Okay, so I want you guys to think through, how does an insurance company make their money? You pay for insurance. Then they make money. All right. So if let's go ahead and say Miss Meister is driving her car and gets into a car accident. Okay. And the cost of my accident is they have to total the car, and my car right now is worth roughly $16,000. Okay. Since owning that car and having it insured, I've paid roughly, I don't know, $2,000 in car insurance fees. By the way, my premiums are much lower than your premiums. We'll talk about why in a second. Okay? So I've paid them $2,000, but they have to pay me $16,000. How are they making any money?
Because not everyone just totals their car.
Not everybody totals their car. You guys get what I'm saying? And so what they happen is, so they know about how many people are going to total their cars. How do they know that?
Statistics.
Do you know how long we have data for about who gets in, about like how often people get into car accidents? Do you know how much data they have? They have a large amount of people over the years of their company, yeah? All right. So they know the probability when they insure somebody, they know the probability about what percent of that large number of people are going to get into a car accident. And that's how they decide how to price their insurance. By the way, is it fair that my auto insurance is a lot lower than your auto insurance? Yeah. Totally. Why do they give discounts to people with good grades? You know that they do that, right? If you have good grades, you're going to pay less for your insurance premiums than if you have bad grades. It's not because it's not like a judgment call. They know that they like have the data that supports people with bad grades don't get into more or do get into more accidents than people with good grades. They know this. It's not like judging on intelligence. It's not judging on responsibility. It's data that already tells them that they know those probabilities. Do you guys see what I'm saying here? Okay. Certain features on your car can get you a discount on insurance. Did you know that? if your car has like the braking for you, right? The radar on the front or whatever that brakes for you, your insurance is going to cost less. They do that thing where you plug in the little computer and they see how you drive for 6 months. Do you guys know what I'm talking about with that? Then your insurance costs less, probably. Okay? Why? It all comes back to making a decision from a probability. It's the same with how do they price phone plans for getting the like Apple Care warranty or whatever. Okay? So this is a kind of simplified example, but all of this is you pay a premium. You probably won't have to. They probably don't have to pay you out, but you pay that premium just in case. And everybody who they don't have to pay for pays for everybody that they do have to pay for. Does that kind of make sense? Okay. So we're going to operate on this question about that they're not trying to make a profit. They're just trying to break even with this particular policy, which, by the way, is untrue for every single insurance company. They want to make a profit, no question, okay? All right, so the cost, let's go ahead and say that the cost to replace a phone is $150. This is obviously a relatively old question, okay? The cost to replace a phone is $150. And you're not going to pay $150 for a warranty if the phone costs $150. Why not?
Then you might as well just not.
You might as well wait and see if you break your phone or not. If you guys with me? So the warranties, insurance costs way less than the accident themselves. Okay? All right. So if I take a sample of 20, am I guaranteed that one of those 20 is going to break their phone? No. Is when someone runs this warranty, are they only going to have 20 people? No. So what we're about to do, it only works because the company would have a large number of clients. Okay, so how much should they charge if they want to break even? 1/20th? 150. Because if they do that and they only pay for 1 in 20, the 19 other people of those 20 will cover the rest of the cost. Does that kind of make some sense? $7.50. Does that feel about right? Now, does this mean you probably shouldn't get the warranty? Guess who never ever gets a warranty on her phone? Why? I've never broken a phone. Have any of you broken a phone? Have any of you broken more than 1, 2, 3, 5?
I think 4 or 5.
4 or 5? You should get the warranty. Right? Like, it's a good... Everybody has, like, different opinions on, like, all this kind of reasoning process, right? But if you're someone who doesn't break their phone very often... I mean, the other component, I once asked my dad, should I, like... Because my dad is kind of like Mr. Richards, except for softer and kinder. Actually, you guys, Mr. Richards is one of the kindest people I know. He's not soft. You guys know what I'm saying, right? Except for Have you ever seen him around a baby? It is adorable how much that man loves babies. He's kinder than I am if a baby is around, because, I don't like babies. Not my jam. Not my jam. So, but my dad is like, when I have a question about anything financial that I want to make sure I'm thinking all the way through, I go talk to Jim Meister, because that's who he is. And I love that he is that guy for me. So I was driving a really old car. I was struggling to save money. This was in my first and second and third years teaching. No, it was in my 10th year teaching. And I really needed to save some money, and I was like, I could lower my premiums if I switched to liability only. This is what my dad said. He says, what would happen if you totaled your car? How much trouble would you be in financially? And I was like, a lot, because I don't have a down payment. I don't have anything. He's like, yeah, then you need your insurance still. You guys know what I'm saying? There's all sorts of thoughts that we want to weigh into those kinds of decisions. Lots of variables. Okay, so let's talk about these myths about randomness. Okay, you guys? I'm going to add a few more here. These are all different coin flips. Which one is most likely? All of these are equal. All of them. In likelihood. Now, if I were to say I'm going to flip 6 coins, about how many heads and how many tails would you expect me to get? There is a difference in, say, the probability of getting 3 heads and the probability of getting 4 heads flipping 6 coins. There is a difference in those probabilities. Okay? But that's because there are a ton of ways to get 3 heads. There's only one way to get 6 tails. Do you guys get what I'm saying? Okay, this one has 3 heads, this one has 3 heads, this one has 3 heads. Kind of like Fluffy the magical dog. Lots of heads. Okay. Thank you for smiling at that joke. I needed it. I thought it was funny. Okay, here's what the law of large numbers says. Okay? Law of large numbers says probabilities only hold for a large number of trials. And here's how everybody misuses the law of large numbers. Have you guys ever been watching either football, well, not so much, maybe football with kickers, or a sports game, whether it be, it could be somebody playing basketball, shooting free throws, and the announcer goes, oh, he's a 90% shooter, he's missed the last 2, he's due to make this one. Have you guys ever heard that? Or a baseball player who's 0 for 5, he's due for a hit. Or, I don't know, a teacher at Grandview Heights High School saying, we've bought so many tickets, we're definitely going to win this time. You guys, we didn't win, and we've bought hundreds of tickets over the span of me working here. Thousands of tickets, arguably, okay? All right, so on any given ticket, on any given at-bat, at any given shot at the free throw line, how many trials is that? 1. And once something has happened, it is no longer a trial. Are we comfortable with this idea? So the number of trials is always the one in front, not the one of what's already happened. You can't let what's already happened count as your large number of trials, because it's not a trial anymore. It's a known outcome. Does that kind of make some sense? So there's very few times. No, I'm trying to think. I cannot think of a time where you can say, oh, I'm due to get this one right, because I got the last 4 multiple choice wrong, and it's 1 in 5, so I'm probably going to get the next one right. Your probability has not changed. And in the same way that if I say somebody's a 25% free throw shooter, actually 25% is way overestimating my ability. Okay? Someone's a 25% free throw shooter. If they go up to the, let's say they've missed, or they've made the past 8, are they due for a miss? No, and in fact, what's the probability they're going to make it the next time around? It's the same, right? Are you guys with me? So we're not going to say anybody's due for anything because that shows this huge misunderstanding on the concept of chance behavior. Cool? All right. So oftentimes we like to use something called a probability model. A probability model is just all the outcomes and their probabilities. So, I did that yesterday too. So if I have this spinner, right? Okay. It has a red, a yellow, a green, and a blue. And each of these has a probability of 0.25. This is a uniform probability model because they all have the same probability. Not everything works that way. Okay? And so every outcome, is that every outcome on the spinner? If we ignore the black lines and just call those respins. Okay? And how do I know it's all of all the outcomes? They add up to 1. Cool? All right. Okay. You guys. So a lot of times what we do is we assign capital letters to different outcomes. Okay, so for instance, what is the probability I get a red? 0.25. What is the probability I do not get a red? Do you need Kleenex? 0.75. Okay, so I'm going to introduce a notation to you. We're going to call that red, and when we put this little, it almost looks like an exponent C. Sometimes we use a prime, like a singular quotation mark. And it means something totally different than the calculus prime. But I use C 99% of the time. The one I'm going to use is going to be C. You might see it as a prime. Okay, and that C stands for the complement. The complement of an event is everything that is not that event. And you said 0.75, but I sure do like to know where numbers come from. So where did that come from?
It's the remainder, because it has to add to 1.
Yeah, you just take, so the first probability rule that you guys are going to learn is that, in terms of probability formulas, is that the complement of an event is 1 minus the probability of that event. Now, if I say something is a 25% chance of happening, and I say what's the probability it doesn't, is 100%, or is 75%, how many of you knew that going in here? Cool. This is just formalizing something you already knew. All right. So in this particular case, we're asking is, we got a group of people, a college a set of students at a college in which 57% are between the ages 18 to 23. And I'm going to shut up now at this point. Do you guys get what this table is telling you? All right. Is this a full probability model? Does this appear to be... How would I know?
If it adds up to 1.
If it adds up to 1. Is this 100% of the students? Well, I don't know. One of you guys out there with a calculator, I feel like this is like one of those instances where y'all are a lot smarter than me. Do those add up to 1? Feels like they might. They do. Yeah, great. Yes. It is a complete probability model. Okay. All right. And so next we're saying the traditional college age group is going to be 18 to 23. What is the probability somebody is not in the traditional age group? What would you do?
1 minus 5 times.
Okay, you guys, I got to tell you this, because it made a lot of people angry with me, okay? And I don't like it when people are angry with me, so I'm telling you this in advance, okay? Maybe 5 years ago, there was a free response question on my Unit 4 test. It was my test, not theirs, okay? So it was the one that I graded. And a whole bunch of people wrote this, and they didn't show their work. And on this particular, so they earned a P for that section. You guys with me? And that P took their grade down by an entire point on that free response question. Do you guys see what I'm saying here? Because they didn't show their work because they thought it was such an obvious thing to do. I want to reinforce this idea that don't write down a number that I didn't give you without showing where it came from. Everybody good? How else could I have gotten to this answer?
Adding up.
I could add up the other 3 categories, and that's totally fine. No problem whatsoever. Cool? All right. And, all right. Ooh, 2 events are mutually exclusive. Have you guys heard the phrase mutually exclusive before? What does it mean? Yeah, I kind of figured we might be there. Okay. 2 events are mutually exclusive if one event occurring excludes the other one, or vice versa. In other words, they cannot occur at the same time. All right, just looking around the room. Zoom and walk you through. The probability right now that somebody is currently wearing shoes with laces in this room is in fact 3 out of 13. Everybody with me? 3 out of 13 shoes that have laces in them. What's the probability of not wearing shoes with laces? 10 out of 13. Everybody good? Okay. Is there anybody in the room that has shoes with laces and without laces? Is that possible?
No.
Okay. So with laces, without laces is in fact mutually exclusive. They can't. If one happens, the other one can't occur. Cool? That's one of my, So, does anybody have another idea of 2 events that would be mutually exclusive? heads and tails. Awesome. How about this? Black and spades. Wait. You guys, those are mutually what? No, they're not mutually inclusive. Black and diamond, like in a deck of cards, right? You can't draw a card that is both black and a diamond. But black and a spade, they have overlap between them. Cool? Right? And so some more probability symbols. So we have event A and event B, or outcome A and outcome B, okay? And so when we're talking about occurring at the same time, that would be an and situation. You're wearing shoes that have laces and do not have laces. Black and spade can happen. Black and diamond cannot. And we use this kind of upside down U. It stands for intersection. Okay? There is no intersection between the black cards and the diamond cards. Yeah? Are there any shoes out there that are the intersection of laced and unlaced?
It's like
They're not laces.
laces, but they serve as laces, or the like rubber
the kids'
things.
shoes that
The
have
magnets.
They have like the laces, but you don't tie them. They just have Velcro on top.
Yeah.
Oh, that's true.
Or the ones with magnets that you
Yeah.
place the magnets into it, and so you
Or like the little like rubber things that they're laces, but they're not like.
I was expecting the answer to be no. Okay? I was going for a no. Wait, tell me, there's shoes with magnets in them?
Yeah, you can lace magnets into your laces, and then that way when you don't have to tie your shoe, you just magnet the magnets together.
Or when you see the like fancy videos online of like, different ways to tie your shoes, to, like lace them up, so you don't actually need to tie yours.
Yeah.
You guys, I'm going to leave this where it is. I'm going to leave it where it is. All right. You guys didn't know this, but your blood cholesterol could be called a probability. Like, someone goes to the doctor, what's the probability that their cholesterol is in this range, is in fact a probability, right? It's a chance process. In terms of a random person going to the doctor, so you're a doctor in a doctor's office, you're doing blood work to do that, like, I don't know if you guys have to do blood work all the time, but when you get old, every time I go to the doctor, she draws blood and looks at blood samples for me, okay? It's like one of those, Indy just had to, my dog Indigo just now, he has to get blood drawn every time because he's considered a senior dog. Don't tell me about it. He's my first ever dog. And I'm like, he's starting to go gray.
Powdered sugar things.
Huh?
Powdered sugar things. Well, some people call them powdered sugar.
Well, so, because he's, yeah. But since he's the black one, so it actually looks like salt and pepper, which is super lovely. Like, he looks very distinguished and handsome, plus he's always wearing his tuxedo everywhere he goes. But it just, the idea of him being old makes me so sad because he used to fit in my hands. And now he's 75 pounds. I digress. Okay, so here we have event A is a person with a cholesterol level above 240. Event B is between 200 and 239. Okay? Are those two events mutually exclusive? Yes, because a person can't have two cholesterol levels. Okay? So, using your gut, two people. Oh, by the way, did you see I gave you the two probabilities of those events independently of each other? Okay. All right. What's the probability of a random person walking into their doctor's office getting the blood test to check their cholesterol? What's the probability that they have either high or borderline high?
0.45.
So that would be A or B. By the way, that symbol is called the union of two different groups, okay? And your gut is telling you we should do 0.16 plus 0.29. We don't just get an answer. We show the work that, and we can do this. If those two events are mutually exclusive and there's no overlap between them, we can just add together. Their probabilities. Lovely. All right, what's the probability they don't have any sort of high cholesterol? Their cholesterol is normal,
1 minus.
which we've defined as the event C, but it would be equivalent to saying A or B complement. They're the same thing. We do 1 minus that 0.45. So far, have I done anything that you guys are like, whoa, this is impossible? I wasn't trying to be impossible yet. All right, I'm done.